My name's David Garrett and this is my assignment for Emerging Pedagogies and New Media. My curriculum specialization is science, and as a future science teacher, my ideal classroom, physically, would be very similar to what's already available in most high schools around New South Wales. What I would really like to talk about today is the ICT features, more so than the architecture, that you can include in a classroom to help present and conceptualize information for students. One of the things that is not so readily available is a visualizer. And I think these would be very useful for typically any task that you would normally do writing on a whiteboard, such as mathematical equations or drawing diagrams, because essentially you can draw or do the equations on a piece of paper while facing the class so that you can keep eye contact with them. And plus, at the end of the day, you've got a piece of paper with all the work that you've done in the class, which you can photocopy as a handout or load up onto the web. Perhaps another excellent use for a visualizer would be for demonstrations, where the detail of handling something that's rather small can be magnified up onto a screen so that the whole class can see it at the same time in much better detail than might be possible without it. Another possibility is Lectopia and Illuminate, so you can record everything that goes through the visualizer and upload it as a video onto the internet later. Another excellent tool for a science teacher, I think, would be a class website. So here's an example from Batesville, and as you can see, there's just a list of, this is the contents page, I guess. There's a bunch of links to all the different parts of the course that you can upload information, handouts, tasks, and links to other websites that the teacher might find important. And you could also have a blog. You could also have a blog or a discussion board for students to discuss the content of the course and any questions that they might have. This is a clicker. I think this would be really useful in my classroom for a variety of reasons. I mean, if you ask a question in class and students aren't confident enough to put their hand up to answer the question, they can just click a button on their clicker and their response is contributed to an inclusive result at the end, which you can present to the class, and they can see how their ideas rate with other students in the class. And also, each clicker's got an individual code which the computer can record, and the teacher can analyze later to see if there's any students that may be struggling, and this may not be possible without such a device as a clicker. Another excellent tool that I think would be highly useful is the set of devices you can get from companies like Pasco, which are essentially data loggers. So you can log things like temperature or motion. And so here's an example where students can set up an experiment and collect raw data from the motions of a weight in a spring to analyze simple harmonic motion, which otherwise would be very difficult to do, at least accurately, without devices such as these. And perhaps the most important aspect of ICT in a classroom is the ability for students to visualize abstract things that would otherwise be limited in a traditional classroom to diagrams, graphs, or equations. So I think this quote pretty much sums up what I think about it, is that the trick is not to turn experience into abstractions with a computer, but to turn abstractions like laws of physics into experiences. So an example of this is the Colorado website, where they have a huge array of different applets that you can use, Java applets, that explain different aspects of physics and all different elements of science. You can see there's on the side here, you've got not just physics but biology, chemistry, and the rest of them. Perhaps one of the more interesting and useful ones that I found was this one to do with gravity and orbits. So here's the application running. You can see there's a whole bunch of different scenarios you can choose from. There's a bunch of options. You can show forces of gravity, the force of gravity as a vector, the velocity as a vector, and maybe track the path. Change things like the mass of the star or the planet. So we'll just quickly show you what it looks like. Okay, so typically students conceptually don't find it too hard to visualize a circular orbit, but you can play around with all these different options and you can create orbits that are perhaps a little more difficult to visualize, like elliptical orbits. So if we increase the mass of the sun, the planet will tuck into a tighter orbit and end up in an elliptical shape. So far as physics goes, perhaps the two most difficult concepts to visualize for students is relativity and quantum mechanics. And here on at this website, you can get what is probably my favorite use of ICT to visualize or conceptualize abstract principles. So here's a simulation, and essentially it's just for students to experience some of the things that would happen at high speeds, the relativistic effects such as Doppler shifts and aberration, which are otherwise very difficult to conceptualize. So that essentially summarizes what I would have in my classroom as a 21st century classroom with ICT. Here's a list of references for the images that I used and the quote, of course. Thanks for watching.